D has dimension of length L and unit of meter, T has dimension of time and unit of second, and M has dimension of mass and unit of kilograms, then what is the dimension and unit of U equals D over T? Okay, so the first part here, right, so the dimension of U equals the dimension of T divided by dimension of T, and this is a length and this is a time, and the unit would be meters per second. That's okay, isn't it? Yeah. Alright, so for B, V, the dimension of V must be the same as the dimension of U, or well, if you want, it must be the same as the dimension of U plus AT. And these can only be added together if they're the same dimension, and these must be the same as this, so you could just say it's the same as U, which is also meters per second, so that's okay. Now, the dimension of AT must be the same as the dimension of U, so that means the dimension of A is the same as U divided by the dimension of T, which is U we said was length per time.
So it's length per time square, right?
Yeah, length per time, and there's another time there, so it's length per time squared, so that's meters per second squared. Yeah. Okay. Next you have dimension of F equals dimension of M multiplied dimension of A, which will be mass times length time minus 2. So that's kilogram meters per second squared. Okay, and lastly, if F equals G M1 M2 over D squared, then that means that G equals F D squared over M1 M2. So then that means that the dimension of G is the dimension of F, dimension of D squared over dimension of M1, dimension of M2, which would be, so the F we just had is M L T minus 2, and now the D squared, that will be L squared, and then this is an M, and then this is an M. So this will cancel with this, so you're left with length cubed, well, yeah, okay, length cubed T minus 2 M minus 1. So that would be meter cubed per second square per kilogram. Something like this. Yeah. How close did you get to getting that now?
Not close.
Not close. No, that's okay. What was the difficult part? Where'd you get stuck? Alright, okay. That's alright. Does it make sense to you now?
Yeah,
That's good, okay. 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 Next one. Oh, you need a minute?
yeah.
Yeah, that's okay. There's no rush.
Okay.
Yeah. Okay, great. Great. Right, next one, number 2. So this one is an important one as well. Converting between different units. So you wanted to change from millimeter squared into meter squared. So that would be 62, this is A, 62370 millimeter squared, 62370 millimeter squared, which is 62370 0.001 meter squared. Okie dokie. Now, sorry, and I can,
And you have the square root.
yeah, I have a 0.001 squared times meter squared. So let's see what we get. 62370 times 0.001 squared. So you get 0.06237 meter squared. That's okay, is it? Yeah. Okay. Next now, you want this in centimeters squared. So the trick here, you want to put centi squared and centi squared here and meter squared, because this is just 1. You're multiplying this number by 1, so it doesn't change. But what you can do, centi squared, and this is centi squared meter squared. You now can get your centimeter squared here. So this would be this number you got before, divided by 0.01 squared, because it's the centi. Oops, oh goodness. So what did you get?
623.
Good. Yeah, 623.7 centimeters squared. That's okay as well, isn't it? Okay, number 3 now. The mass of hydrogen is 1.67 times 10 to the minus 27. And hydrogen we can consider it as a sphere of radius 5.29 times 10 to the minus 11 meters. What is the density? So density is mass over volume. And I give you a formula for the volume. It's 4 over 3 pi r cubed. So that would be 1.67 times 10 to the minus 27 over 4 over 3 pi 5.29 times 10 to the minus 11 cubed. That's okay so far? Yeah? Let's see what we get. Right, I got 2693.15, so I'll just drop that, kilograms per meter cubed. Did you get something similar or not? Okay, what did you get?
7.54 times 10 to the power of negative 80
Something sounds wrong there. Do you want to double check your calculation? Do you have your calculator? Right, we'll continue then. Is this recording? Oops. Yeah, it's recording. Okay, so the next part, that was part A. So now part B, you want this in grams per centimeter cubed. So the question then really is, change this from kilograms per meter cubed into then grams per centimeter cubed. So firstly, I'll pull out that kilo, it's 1,000, yeah, G meter cubed, so that would be 2693000 grams per meter cubed. And then what I'll do is I'll introduce a centi, well, yeah, I think, you know what, actually, to make it a bit clearer, I'll just put the meter cubed underneath the G. Grams per meter cubed, like this. And then I'll introduce here a centi cubed. So this would be 2693000 times centi cubed, grams per centi cubed meter cubed. So that would be 2693000 0.01 cubed grams per centimeter cubed. So let's see what we get here. I get 2.693 grams per centimeter cubed. 0, 2693000 cubed. Yeah. Yeah? Okay. Okay. We're happy with this first one? Yeah? Alright. Let's stop that and have a look at the